Asyle, Tropical Island Survival, Week 10, Day 1. The rain seems to have finally let up, which is welcome news, and now that it has, I want to set my sights on eliminating one last non-renewable resource problem. The problem of firewood for cooking, distilling, and possibly even smelting metals, though that might be a stretch. The only other significant source of thermal energy here is the sun, and while I've been able to experiment with solar thermal power by using the black distiller bags, I really want to scale this up, especially knowing that the bigger I build, the more likely I am to be seen and rescued. Plus, the bagged water still tastes kind of funny. I want to create a concentrated solar power station. I think I can make reflective panels using glazed ceramic plates, since the glaze gives them quite a shine when viewed at the right angle. However, glazed ceramic by itself won't be enough, as I'm aware that even a pure glass mirror only reflects 80 to 90% of the light that hits it. Most other materials, like clay pots, would surely reflect even less, say 20 to 40%. If the reflectors are less efficient, I'll need more panels to create the same amount of heat. I could try making them white, which may reflect with 75 to 85% efficiency, and I already know how to make white paint by making lime, just like the Teotihuacanos did back in Central America. However, a lime coating by itself would be matte and scatter light in all directions, like wall plaster. Furthermore, when firing glazed pots in the kiln, the salt and silica in the clay react to produce what I can only assume is sodium silicate, which is what makes the pots shiny, let's say about 65 to 75% efficiency. However, if I coat the clay in calcium hydroxide first to make it white, the salt won't be able to reach the silica, and will instead sit next to the calcium hydroxide doing nothing. Maybe if I just used lime instead of salt water, the atoms would trade the sodium for calcium in the equation, creating calcium silicate, but I don't know if that's going to be a shiny material or not. I weighed the options in my head, shiny but brown, or white but diffuse. I know there has to be a way to make the clay white, because I've seen white plates before. I considered mixing various amounts of lime into the clay I have in order to make it whiter, but would that add to any light reflected by the glaze, or simply average with it? And would that light simply diffuse because it's white? I need it to reflect. I imagine the glaze basically acts like a clear window, and at just the right angle, it reflects most of the light that's hitting it, its angle of total internal reflection, which is usually quite shallow. The rest of the light passes through. As I think about it, even if the underlying material is white, most of that light is going to scatter in all directions, and only a fraction of it will be reflected off at the same angle as that of the glaze. If the glaze is reflecting, at worst, 65% of the light, then any lime underneath would only reflect another 45% of the remaining 35%, or an additional 15%. That would boost it to 80 or 90% of the light hitting it, which doesn't pass a reality check, since that would make it as good as a regular mirror. With that figured out, I guess that means some glazed ceramic plates will be all I need. No need to go through the additional rigmarole of whitening them. Next, how many am I going to need? I know that the Earth receives about 1,000 watts per square meter of sunlight each day, and I estimate it's going to take maybe 10 times that much to power a proper oven. If we go with the lowball estimate of the plate's reflectivity, about 65%, then that means I'm going to need 13 square meters of reflectors to get the array hot enough, rounded up to 15 square meters to be safe. That's not too bad, actually. Altogether, that's an area of 4 meters by 4 meters. Another factor I need to keep in mind is total internal reflection. Even for transparent media like water and glass, there's an angle at which light can hit it, and all the light gets reflected, and none of it passes through, which would make my plates functionally perfect mirrors. For glass, this is about 45 degrees, and any smaller angle of incidence will work just as well. If I use this method, though, the plates will have to be bigger to cover the same incident area of sunlight, more like 32 square meters of actual plates. And another thing I realize as I draw out various ideas in the sand is that, unlike normal concentrated solar power plants, I can't just put a whole bunch of plates on the ground and point them up at a tower. Because of the angle the plates will need to be at, the focal point actually has to be below the mirrors for the most part. This changes the design if I want to use total internal reflection. Finally, there's the factor of thermal emissivity. I want the kiln to absorb light and turn it into heat. That's easy to do by making it black. However, this is a double-edged sword, because the hotter things get, the more heat they give off as infrared radiation, and the color black radiates heat just as well as it absorbs it. This fundamentally cannot work just one way. I could try to be clever about using the mirrors to reflect light and heat in better than they reflect it out, but in the end I may not need to. Things can only radiate heat if they're hotter than their surroundings, otherwise their surroundings heat them up. But because of the mirrors, the only thing the kiln can see to exchange thermal radiation with is the blazing hot sun. So even if the kiln could get up to 1,000 degrees Celsius, it would still have at least another 4,000 Celsius to go before their internal temperatures / thermal radiation balanced out. Of course, in real life, things don't work that way. There's going to be additional heat being lost through the air and anything touching the kiln, but these losses could be minimized in various ways, and I'd honestly be happy to get a kiln that's hot enough just to boil water, or even cook pottery. The physics alone seem to suggest that it's possible, though practical nature will probably get in the way at some point. Still, it sounds like as good a reason as any to give it a try. Having spent at least an hour planning out the design for the kiln, I decided to start building. Fortunately for me, after the downpour last week, there was plenty of water and mud to be had. Obviously, I couldn't make a single massive reflector of the proper size, nor would I want to, since I need it to remain somewhat flexible, so I made little clay plates that I can handle and assemble more easily. I made a prototype plate which was flat on one side, but with handles on the other so I can attach it to things, almost like a big button. I recognized that I needed them to be as uniform as possible, so I switched tact and started making a mold for mass production, though it'll need a day to dry and fire before I can really start making many more plates. I decided to make the reflectors hexagons so they'll tessellate and flex relative to each other without making large gaps. The reflectors will be about 1 square foot in size, and my protractors made it easy to get the angles of the hexagonal mold just right. I used a piece of split bamboo to make sure the bottom of the mold was perfectly flat, and my tape measure to make sure the mold was the same depth everywhere. Once finished, I left it out in the sun to dry. In the meantime, I thought I would spin up a few less uniform reflectors on the potting wheel to make the most of the kiln time. While I could only fit 1 stack of reflectors in the small kiln, I should be able to fit up to 4 in the kitchen kiln. The plates will need to be as thin as possible since they'll be very heavy, but they also need to be strong so they don't break. So I went with a thickness of about 1 centimeter. Since the kiln is 3 feet tall inside, I could fit a stack 90 plates tall in it, though probably half that to leave room between them, or 45. That's 180 plates, with a total volume of 6 cubic feet or so, which is just over half the area I need for these reflectors, which was way better than I was expecting. I thought I might not need the mold after all, but I'm going to use it anyway, since turning plates on the potting wheel takes so much more time than slapping them into a mold. I'm losing a day by waiting for the mold to dry, but I'll save myself hands-on time in the long run. If I can dig up at least 1 cubic foot of dirt per minute, and it takes at least another to slap it into the mold, then it should take only 12 minutes to make them all. A bit more for the handles, so call it 5 minutes per plate, or 30 minutes total. No time at all, but that's for a later day. Instead, I needed to start working on another aspect of the array, one that would ideally take the most waiting, so it seemed like the best thing to do, again since there was so much mud lying around, was to immediately start working on the kiln itself. I got some thick bamboo and branches to build the structural lattice that I would fill in later. Now while I was building this frame, I got an idea. Instead of shining light directly onto the outside surface of the kiln, where it would just radiate off again, I could make little windows to direct the light inside the kiln. If I make the focal point of the reflectors as close to those windows as possible, the light will spread out again inside the kiln and be absorbed and re-radiated by the walls. Any radiant heat that gets out will have to pass through those windows, but because they're the focal point for the mirrors, this will direct most of the heat straight back into the sun, which will just send the heat straight back in. The only problem I saw with this was that it would give the heat a place to escape via convection, like a chimney, but there might be ways to minimize this. I'll keep it in mind. Even if the windows don't end up working, I can always seal them up and go back to my old plan of painting the outside black and shining light onto it directly. Either way, I was still presented with a little design problem for the kiln, and that was the fact that I can't put a door on it, which would get in the way of the absorption surface or create a crack for heat to escape via conduction. That meant I could only load and unload it from underneath, which would be a bit inconvenient and still create a convection path. I could tell that I'd kind of jumped into this project without planning everything through yet, so I took a step back to think. If I'm going to need some kind of dumbwaiter to load the kiln, that's going to require it to be a bit taller than I was anticipating, so I'm going to have to build some kind of elevated platform for it to sit on first. This isn't too big a deal, however, because I'm going to need some rigid structure anyway to connect the reflectors to, which will have to be sturdy and support the kiln's weight. That was a bit more work than I bargained for today, but one way or another I'm going to need a kiln, and I'm probably going to need to make it movable to some degree. So I got back to the frame and gave it a nice, flat, sturdy base that I could roll it on, before finally filling it in with pumice and clay to dry. This kiln has similar dimensions to the one in the kitchen, about 2 feet in diameter and 3 feet tall, with a domed ceiling, though no chimney. Just a bit too small to fit a person in, so I can't get Hansel and Gretel by accident. Old engineering habits die hard, and good thing too. The walls were about 4 inches thick for good insulation, only about 10 cubic feet of total volume, and most of that was pumice, so it didn't take too long to completely fill in. I made sure to cover the bamboo frames around the little windows with clay to protect them from the heat. With the kiln drying and what was left of the afternoon sun, I worked on cooking up some lime before it finished setting. Yet another thing I probably should have thought about ahead of time. I painted this on the outside of the kiln to minimize any heat loss to radiation working its way through the walls of the kiln. At the same time, I used the fire as an opportunity to make some charcoal to color the interior of the kiln for maximum light absorption and heat radiation onto anything I put inside. I couldn't just paint the charcoal straight onto the walls of the kiln, however, otherwise it would eventually burn off and have to be replaced. Instead, I mixed the charcoal with some clay to make it black. However, when I went out to put it on the kiln, I realized I'd locked the proverbial door from the inside, since I had to get under the wet, unstable kiln to paint it. I got some sticks and carefully jacked it up onto some rocks and logs until it was just high enough for me to get under it. I made sure it was absolutely stable first, though, as the weight of the thing would probably have crushed me to death if it got loose. Another price to pay for not thinking things through. I re-wet the surface and began applying the black clay to it, using fresh water instead of salt, because I didn't want it to be glazed. I wanted it to be as matte and absorptive as possible. As I went, I used a handful of sticks to give the clay a spiky pattern. This was based on a material I heard about when studying semiconductors called black silicon. It's basically silicon that has been made into a forest of millions of tiny needles. And while the silicon itself is not black, light has to bounce around so much in those needles that most of it gets trapped and absorbed. I wanted to try and take advantage of the same effect here if I could. It was getting dark by the time I finished, so I frantically coated the outside with lime plaster before the sunlight completely went away. At least the lime was easier to see in the twilight, though I still had to do a fair amount by lamplight. When I was done, I washed my hands and chided myself for my lack of planning today. I was not going to make that mistake again, so I took some time to plan my moves for tomorrow, and sleeping on those plans will give me an even better chance of spotting mistakes in the morning. Week 10, Day 2. I got up in the morning with a clearer idea of what needed to be done, which involved getting the reflector mold cooking right away. After completing my morning chores, I decided to start working on the support platform for the kiln. It needed to support the weight of the kiln, the weight of the reflectors, and the weight of the supports I'll attach the reflectors to. I mentioned the plates will have a volume of about 6 cubic feet, and the kiln will have a volume of about 10. Call it an even 20 cubic feet total just to be on the safe side, and to account for the reflector supports. The supports themselves will be made out of bamboo and not weigh much at all. The density of clay is about 2.65 grams per cubic centimeter, which was easy to measure in my lab, so the platform will need to support a weight of at least 1,431 kilograms, 715 kilograms for the kiln, 430 kilograms for the plates, and 287 kilograms for the supports. Not as bad as I feared, but still a lot. Nearly 1.5 metric tons, or 16 times my weight. It seems just small enough to be doable, though. This then led into the additional complication of the reflector panel designs. Part of the problem, no matter the shape of the reflectors, is that the sun moves, so the panels will need a way to follow it throughout the day and keep light focused on the kiln. One option was to build the array as a single solid piece, like a satellite dish, and move it to follow the sun. But my concern was that this would put a huge torque on the base of the platform from the weight bending back and forth. The other option I could see was making several small panels, like the petals of a flower, which would individually flex and follow the light. This design was much more complicated, but had the benefit of each panel counterbalancing the ones opposite to it. I have to admit, the latter appealed to me largely for the biomimetic beauty of it, but I felt it also had the benefit of being modular and therefore easier to repair or replace parts when something inevitably breaks. This will still cause some torquing of the platform, as the panel's shifting sides will shift the array's center of mass, but not nearly as much as a solid dish. Either way, this constrained the platform to be relatively wide, and probably sunk into the ground a bit to handle the torque. At the same time, making the tower taller should minimize the amount of counter-torque the Earth needs to apply to keep it balanced, though also the more the platform itself may bend. If I'm going to use moving panels, however, this presents a new problem. I was planning on the panels forming a parabola, which would focus all the light hitting them to a single point, and into the kiln through the little windows. However, if the panels are going to move, they'll need to hinge at the focal point, otherwise they'll shift the focal point up and down as they move, and obviously they can't shine light into the kiln if the hinge is in the way. This will therefore require me to put the hinges on the sides of the panels and tangent to the kiln, more like posts that the panels can bend off of. And they'll have to be tied to each other in such a way as to translate the force from one side of the structure to the other. I'm thinking of using an array of 6 panels arranged in such a way that they can share posts at their corners, and to make sure that there are no gaps between them, I was thinking of putting a second array of 6 panels slightly below them to cover the gaps, again like the petals of a flower. But then I realized that the posts themselves would be in the path of the light reflected by the lower panels. So that's 6 sturdy posts in total, each having to bear a weight of 120 kilograms, and a maximum torque of about 2,600 Newton meters for panels about 2.2 meters long, and their center of mass at the very ends, as a worst-case scenario. That torque is what's bothering me the most, and the best way to counteract it will be to apply support at the ends of the panels, like a rope on a suspension bridge. This will end up converting that torque mostly into a shear force at the hinges, which wood is good at handling perpendicular to the grain, and tensile force in the ropes, which I can tie off to another post where the tensile force goes straight into the ground, or onto a pulley that would make the panels easier to control. I know this seems involved and long-winded, but most of this stuff actually flashes through my mind in an instant, before even having done any math. It just takes a long time to accurately describe. And once again, by tying the posts to each other, they can largely cancel out the static forces acting on each of them. In hindsight, it would have really helped if these posts were part of the kiln itself, but this is the price I pay and rightly deserve for my haste. With a solid plan finally established, at the conclusion of my morning chores, I cut down some bamboo. I wasn't sure whether or not to use a cluster of bamboo for my posts, or a whole palm tree trunk, so I decided to start working on the reflector support panels first. As I mentioned, I needed them to follow a parabolic curve, and while it was easy enough to bend a piece of wood into a bow using a piece of string, that wasn't necessarily going to make a perfect parabola, nor would I be able to easily tell where the focal point was going to be. What I had to do first was draw the parabola out on the sand, calculated according to an equation of the form y equals ax squared plus bx plus c, and the total focal length given by the equation y focal equals r squared over 4h, where r is the radius of the parabola, h is the height, and y focal is how high above the vertex the focal point is. I marked out the points of the line with stones, and then used cord to bend lengths of bamboo to the right shape. I found that the bamboo by nature already wanted to bend into a slightly parabolic shape, since one end was thicker than the other and therefore wanted to bend less, creating an imperfect arc. However, it was never going to focus to exactly the point I wanted with each piece of bamboo, so I had to use the cords to bend several smaller arcs midway through the length of each piece. The portable drill helped with this, so I didn't have to take the arch from the beach to the workshop and back again repeatedly. I soon figured out that I could lace a single piece of cord through certain critical points of the parabola, and by changing the tension on that single piece, I could adjust the position of the focal point as needed. This will be critically handy when I inevitably have to make adjustments. Still, making this one support arm has been so involved, and the entire project so far plagued with problems, that I'm starting to feel like I may have bitten off more than I can chew. Again, I blame this on not planning everything through and conducting small-scale experiments first. Anyway, once I knew the method for making these parabolas properly, it didn't take too long for me to make them. About 5 minutes each to drill the holes and thread the cord. So I finished whipping up 12 in an hour before having lunch, knowing that I was going to need parabolas no matter what I did with this machine. Afterwards, I began assembling the panels on the ground around my kiln. Each one needed to be kind of triangle-shaped, and because they needed to form a bit of a dish, I bent the cross braces into arcs, with a maximum radius of 2.2 meters, that of the intended outer edge of the array, and a minimum radius of about 30 to 35 centimeters, that of the kiln. A little cross-wiring of cord in the gaps between them made for a sturdy but flexible panel. Before I made more, I got a pot, filled it with sand until it weighed about 72 kilograms, the mass of the reflectors I'll be attaching to the panel, and tied it to the end of the panel to see how hard it would be to lift. I could barely lift the pot because it weighed almost as much as I did, and there was clearly no way I could bend the panel just by lifting it with my back at arm's length. I'd probably rip my arms off. However, by trying to lift it with a rope tied to the end of the panel and pivoting it at my heel, I found I could lift it quite easily. That's the power of lever arms. This simultaneously caused me to realize another important point, namely that the height the rope is pulled from makes a big difference, since trying to lift it by pulling at ground level was virtually impossible. This means I'm going to have to extend the posts up a bit so the cords can pulley over them. Once again, testing before building is helping me discover things I might have otherwise missed and had to go back and redo. Also, I can't help but notice that, by sheer coincidence, the more I try to make this thing practical, the more it convergently starts to look like a flower. The extended posts may end up resembling stamens. In any case, I finished building the panels. About 30 minutes or so to bend the bows, attach them, and attach cross bracing on each panel, so about 3 hours to finish all 6 of them. I took a minute when I was done to think about what needed to be done next. Even if I had the raised platform already, I can't attach the panels without adding the reflectors first. Then again, maybe adding the reflectors first would make the panels too heavy to move. Either way, I suppose the platform needs to be made next, and while I'm clearly not going to be able to finish it before the end of the day, there's no putting off the murder of another palm tree. This will be my 3rd one. I can see that my axe is starting to look a little worse for wear, so first I'll sharpen the blade a little and reinforce the handle with some bamboo cord. I then headed out, looking for a nice, straight candidate before chopping it down. I took some measurements and cut the trunk into pieces, but I realized at this point that the logs needed to be at least 14 feet tall. A tall, straight palm tree is at least 4 to 5 stories tall, or 32 to 40 feet, meaning I could only get 2 to 3 poles out of it. I need 6, so that meant I needed to massacre 2 more trees for a total tree spree so far of 5. I spent the remainder of the daylight chopping the logs to length before heading back to base, just as it was getting too dark to see anymore. When I got back, the reflector mold was ready, so I pulled it from the kiln. I could probably start making the reflectors tonight and have them finished cooking by morning, but honestly, I'm tired, and I've been pushing myself enough as it is lately. I'll have dinner and go to bed early. There'll be plenty to do while they're cooking tomorrow. Week 10, Day 3. Today I started pulling things together. After my morning chores, I immediately started working on the reflector plates. To save myself a little time, I dug up the clay I needed from the post holes for the palm trunks I cut up the other day. I found the clay around this particular spot had a relatively pale red, orange, or sometimes pink color. I like this actually because it's going to make my array look even more like a giant flower, and that's definitely going to attract someone's attention from the air as surely as a real flower attracts the attention of a bee. In any case, I prepared the clay and slapped it 1 glob at a time into the mold, being careful to dust my mold first so they'd be easier to pull out. I also made 3 clay knobs on the back of each plate, so I could finally control the position and angle of each plate on the panels when I tie them in. Might be overkill, but not too much so. I then found a flat surface and laid them out to dry in the sun for the day. As previously estimated, this didn't take me more than an hour thanks to the mold. With that out of the way, I could continue working on the platform. I left 6 poles in the woods last night. They were big and heavy, and I couldn't cut them smaller, so I built a pair of quick and dirty sledges that I could attach to the ends of the logs and pull. They basically consisted of several pieces of bamboo tied together into a platform, with the front ends curled up a bit and covered by a smooth bumper to keep the sledge from getting caught on things. This took me up to an hour to finish building, but when they were done, they allowed me to drag the logs back to base in minutes with a minimum of effort. It probably would have taken me an hour each without the sledges and left me exhausted. At this point, it was simply a matter of sliding the logs into the holes I made and erecting them with the help of a bit of rope, which didn't take long at all. Most of the logs I tried to drop in or by the holes as I delivered them. Next, I needed to establish them at the proper positions and angles relative to each other, so I cut some bamboo and affixed some light cross braces to each post, each measured and cut to proper length. I placed these braces above where I expected the kiln to sit, in anticipation of future steps. Then I filled the post holes back in with wet clay and stamped it down to make them secure. I stopped for lunch and would like to take a moment to think about what's going to be the tricky business of elevating the kiln into the tower without breaking it. Obviously I'm going to have to get it over there first, but then for the matter of elevating it, do I jack it up a little bit at a time? Or build some kind of elaborate system of ropes and pulleys to elevate it evenly the whole way? Then once it's up, how do I secure and support it? I think the best thing to do is build the support frame under the kiln first, so I'm less likely to cause any further stress to the kiln. This will also give me a larger surface area to provide support on. To that end, when I was done with lunch, I went looking for some thick, straight branches or small logs in the forest, and then cut some notches into them so they sat together in an extended hexagonal formation, before tying the joints together tightly with cord. I then began the delicate process of jacking down the kiln, one stone at a time, to ground level, being careful never to let it tip so far that its center of mass passed over its supports. I lowered it down to some bamboo rollers, and rolled it carefully to the support frame I'd placed under the tower. Next was the process of elevating, and my plan here was to tie the ends of each support rod to their respective posts with a slip knot, and walk the kiln up the posts. This isn't as dangerous as it sounds, because at least one part of the frame will be tied tight at all times, acting as a pivot, and tension on the other frame ends will prevent the frame from ever falling or tipping too far. In essence, if it started to fall, it would jam itself in place, especially since the tower tapers toward the top. The frame gave me a little bit of a lever arm to lift the kiln with, but it was a long and careful process, as I literally inched it up the structure, but I soon developed a rhythm, as I found the most stable ascension pattern. It took me a couple of minutes to lift each corner and adjust the knots, so it must have taken me a couple of hours before the kiln was at its proper height. With what daylight I had at the end of this process, I made the support frame extra secure against the posts, and constructed arched braces beneath it, both for the strength and beauty of that shape. Almost looks Gothic, and the arches provide a narrow entry for me to access the underside of the kiln. Finally, I daubed on some clay to make sure the kiln stuck securely to the supports, and to provide them with some thermal insulation. By this time, the reflector plates were dry, so in the lamplight of my workshop, I took some time to use the grindstone to make sure the face of each plate was perfectly flat. I then dipped each plate in salt water and placed them in the kiln to cook overnight, packed together as closely as possible as planned. I then had dinner and got ready for bed, exhausted but pleased. Week 10, Day 4. I got up and checked on my reflector plates. Some have certainly cracked, but that's why I made more than I thought I would need. After my morning chores, I made a second batch of reflectors, and set them to dry in the sun for the day. Now it's time to finally assemble this crazy apparatus and see if it works. I began by putting the panels in place around the tower, and drilling holes in the posts at the appropriate positions to affix the panels, which then hung down from the tower like wilting flower petals. This assembly process required the use of my ladder to reach the attachment areas on the tower. I then tied some short bamboo segments to the tops of the posts to form simple pulleys, and threaded bamboo cord through them to test how well the frames could be raised and lowered. I noticed at this point that the frames were flexible enough that the application of uneven force on the cords supporting them would cause them to twist. I can use this to make them follow the sun more effectively as it travels perpendicularly to them, almost like a solar funnel. I also thought at this point to make the pedal hinges tighter, so that if the cord supporting them ever broke, the panel would sink slowly to the ground, rather than crashing down and destroying all the reflector plates in the process. I then finally got to the business of attaching the reflectors to the panels, and seeing if the system could support the weight. I had about 60 reflectors to install per panel, and it took me about a minute to install and tweak each one, so it took me about an hour to finish building the first panel. To make the assembly process easier, and to avoid making a complicated spider web of cables to hold everything together, I tied a mesh of horizontal and vertical cords along the backside of the panels, and just twisted a little loop into the little knobs at the back of the reflectors. The vertical cords ended up carrying most of the weight. After building the first panel, I stopped to test how heavy it was and how hard it was to lift and hold in place. As expected, it weighed a non-literal ton, and I could feel and hear various aspects of the panel straining and creaking under the weight. Still, the weight of each panel was a little bit more than my own, so the bamboo could handle it, and it didn't take too much additional reinforcement of the cables and joints to make me feel safer about it. I then stopped for lunch, thinking about how I would need to build some actual pulleys for the cables, so when I was done, I took some time to lathe and assemble them properly in the workshop before installing them on the stamens of the tower. The result was much smoother elevation of the reflector panel, which made me feel much better. I then repeated the testing and tweaking process for the 2 remaining panels I had time to construct today. I used this as an opportunity to test the ability of the system to evenly distribute the weight of the panels, as I designed it to, and I realized that the opposing panels would never need to change their distance relative to each other in order to funnel sunlight effectively, so I used the pulleys to tie them together directly, so they would automatically oppose each other's weight on the system and stay a fixed distance apart. This also gave me an opportunity to conduct some preliminary tests on the efficacy of this system for heating the kiln. Even with only 3 panels active, I quickly discovered that they concentrated an intense amount of sunlight already, which made the interior of the kiln very toasty very quickly. However, because the reflectors were flat, they could only concentrate sunlight on an area the same size as their angled cross-section. So even when I got them all focused to the same point, which was like herding cats already, it wasn't quite concentrated enough to light something on fire instantly, rather spread out in an oval shape, which mostly fits in the slot-shaped windows I made. Of greater concern to me, however, was the sheer amount of effort it took to intensively adjust every single reflector to just the right position, and by the time I finished doing that, the sun had moved, so I had to adjust them again. This is obviously not something I can spend every day doing manually, so I need a mechanism to make the panels follow the sun automatically. I kind of got an idea though as I was working on the system. I noticed as I was adjusting the panels that the main support cables would sag a bit over time if the focal point was near them, and I could watch the light pass across the cables as they sagged. This is because the heat of the sunlight, while not enough to burn the cables, was able to heat them up enough to cause them to expand. I think I can use this to automate the array's ability to track the sun. As the sun moves, the reflection it casts will migrate off of the windows of the kiln. Along that path, I can place not a cord, but a black rubber band, since it will be able to respond to heating more consistently than a wooden cord, and the black color will make it heat up faster and adjust more quickly. Mercifully, the individual reflectors should only require a one-time adjustment. In theory, I could tie each one to a pair of control cords for individual adjustment, but the rubber bands would never be able to tell if the light hitting them was from their reflector or a different one. This would cause them all to adjust and get out of whack simultaneously before settling to the correct position again. With these fixes in mind, I spent the last hour of the day preparing a batch of rubber, which I spread into a mat from which I could cut my rubber bands later. While it sets, I reformed the windows of the kiln with clay to make them a better fit for the ovular reflection pattern of the reflector plates, having given it some time to cool down first, of course. The broken reflectors from this morning gave me an idea to help keep hot air from escaping the windows. I could create a grating of thin reflective panels across the windows, such that light will still be able to reflect in with near 100% efficiency due to total internal reflection, but the area for hot air to escape through could be cut in half and forced to go around a corner that kept most of it trapped. It's something to keep in mind for later. For now, however, it's getting dark, and I'll work on preparing the next batch of reflector panels as I did the first before going to bed, and cook the rubber mat with them in boiling water. Week 10, Day 5. I checked on my reflectors again in the morning, and held on to the broken ones. Once I was done with my morning chores, I got to work on installing and adjusting the next batch of reflectors on the pedal panels as I had before. Once finished, it was time to do a full-scale test of the array. I erected and adjusted the reflectors to their appropriate positions, now that the sun was getting high in the sky. Even the coal-black surface of the inside of the kiln shone a blinding white with 10 kilowatts of solar light and heat. I'd say it's working correctly, though I have no way of knowing yet if it's getting hot enough, nor if it'll stay hot. I decided to play with it a little over lunch to test this, putting a fish on a stick, lifting it up into the kiln, and seeing if it cooked. It did, but it took a while, either because heat transfers poorly through the air around the fish, cooking it mostly from radiant grilling, or because a lot of heat was escaping. I lowered the panels to let the kiln cool before continuing to work on it. I began working on constructing a floor for the kiln using a clay-coated grate of bamboo that I could lift and lock into place, but my axe head finally shattered, so I needed to stop and replace it, which was fortunately not that hard using my grindstone. After that delay, I got back to chopping and took a moment to temporarily press the lid to the bottom of the kiln while it was soft. This will ensure that it sets later with a good seal, and fortunately my bamboo also makes it relatively light. By adding some little shelves to the sides of the support posts and making some of the bamboo pieces long, I was able to easily rotate and lock the floor in place under the kiln for long periods of time. Then I spent some time carefully breaking the extra pieces of reflector into long, thin slats and using the grindstone to sharpen the edges so they had a parallelogram profile. This will ensure that the edges of the pieces will not block incoming light. Now plenty cool, I used some clay to secure these slats into the kiln windows, angled upward to both reflect the sunlight onto the ceiling of the kiln and straight back down onto anything I wanted to cook, and to make it harder for hot air to leak down and out of the kiln via convection. I used one active panel at a time to make sure the slats were angled correctly. With all of those fixes sorted, I decided to finally move on to the challenging bit of making the sun tracking mechanism. First, I used my blades to cut my rubber mat into thin strips for rubber bands. Next, I constructed some additional pulleys and a sturdy framework to mount them to, across the support posts. I then cut one of the bamboo support cords and tied a long rubber band to it, making sure the band could stretch to the full extent the panel would need it to. This subsequently necessitated that the panels be tied to the posts and not each other, but that force could still be distributed by tying the posts to each other. Now, the focal disc of the panels was so small relative to the length the support cords needed to extend, that it would never have been able to cover enough of the rubber band's surface by itself to cause sufficient expansion. However, I was able to get around this by lacing the rubber band across several pulleys near that light disc, so it heated a larger length of rubber band than it otherwise would have, allowing the rubber to extend the entire required distance. I created two such apparati, one for each support cable of a given panel, and each stretching across a different 45-degree angle from horizontal. This was designed such that if the sunlight hit both of the bands, they would warm up and expand, causing the whole panel to lower, refocusing the sunlight back towards the window of the kiln. If the sunlight did not hit them, however, the bands would cool and contract, in turn causing the panel to rise, and a multitude of pulleys would allow them to exert the necessary force to accomplish this for such a heavy panel. If the sunlight only hit one band, it would cause the panel to contract on the hot side and extend on the cold side, due to the support cables being crisscrossed, redirecting the light to return to center. I tested this apparatus on one of the panels by intentionally misaligning it, and within minutes it self-corrected. Simple, yet effective. I'm elated. Now that I know what I'm doing, I can construct and install one for each of the panels, though I must save calibration for tomorrow morning. Once the sun went down, I found I didn't really have anything to do with the final hours of the evening, at least not for the solar kiln project. However, as I was cleaning up the bits of broken pottery from making the window reflectors earlier, I thought that some of the fragments might make good mosaic tiles. It would give me something relaxing and artsy to do on Sabbaths, and would help reflect more light from the lamps at night. I'll keep that in mind for tomorrow, and after I'm done cleaning up, I'll have dinner and go to bed early. Week 10, Day 6. I got up relatively early in the morning, and once the sun came up, I worked on calibrating the solar array, such that it should remain locked onto the sun every morning as its default position. I then went about my morning chores and checked it when I got back, making any and all necessary adjustments. To make this easier, I added some tension knobs to each cable, like those on a guitar, so I could make fine, permanent adjustments. It's now bright enough out to get a clear idea of how well the array is working, and it's definitely hot, as if it wasn't hot enough around here. Now I need to think of what I want to be using the solar kiln for, besides cooking, and with Sabbath coming up, I think I'll prepare something ahead of time and begin working on making some mosaic tiles, even if most of them won't be ready in time. First, I need to think about what colors I want, and while it would be most light efficient to paint the interiors of the buildings white, I want to make a little art. I need a break after all the work I've done. That does, however, give me an idea of something I can use the kiln for right away, so I'll go get some pots, fill them with water and coral sand, and stick them in the kiln. I quickly realized, however, that it was going to be almost impossible for me to lift the pots into the kiln and keep the floor cover level, so I rigged some quick and dirty block and tackle to lift it into place. But I'm making a note to build a sturdier system later. While they cooked, I had a look around the kitchen, workshop, and lab, and thought about what kinds of mosaics I wanted and where I wanted them. I couldn't even put a mosaic in the beach hut if I wanted to. The truth was that the lab and workshop don't really need much, and I didn't think it was appropriate to their function. The lab could use some tiles on the floor for spills and whitewashing on the wall. At most, I think it would be cool to make some tiles of the periodic table of elements to go on the wall. The workshop really only needs white panels for the ceiling, too. The one place a decorative mosaic would be appropriate, however, is the kitchen, and it makes sense to decorate it with the things I prepare there, the plants of the island and the fish I catch from the sea. So I made a trace on the ceiling of the motifs I wanted to put there, and noted the colors I would need, mostly blues and greens. I was thinking of using an ancient Mediterranean stylization, like those of the ancient Greeks or the Minoan civilization. Next, I decided to prepare some tiles for cooking, which will be a good test of whether the solar kiln can cook pottery effectively or not. I dug up some clay and decided to reuse the reflector mold for making my mosaic plates, since it's already used to make thin tiles. Then, to make sure they were easier to break off later, I took a piece of bamboo and pressed it into the tiles while they were soft. This created lines of weakness in a largely hexagonal pattern, which should make them easier to break into usable pieces. Again, I made them hexagons because I felt like they would make it easier to construct highly tessellated patterns. I then left them out in the sun to dry for the day. I'll probably have to cook them overnight the old-fashioned way if I want to get them done by tomorrow, unfortunately. As for coloration, I was thinking of incorporating the color into the glaze rather than the tiles themselves. I can definitely get blue from the copper sulfate deposits, though I don't want to use it too much. And I can get green from crushing the pale olivine crystals from the caves all over the island. Before I went on a pigment expedition, however, I had lunch and checked the array. I made adjustments and noted that certain panels were habitually lagging more than others, or moving too fast, suggesting their cables or rubber bands needed to be shortened or lengthened respectively, which were easy enough adjustments to make. I then headed to the caves and collected the pigments I suspected I would need, along the way periodically digging holes to check and see if there was a better color of clay underneath the topsoil of the island. When I returned, I ground down the olivine crystals in particular in the mortar and pestle I had in the lab. One problem I saw was that these mineral pigments didn't suspend well in the water, salt or otherwise, and so wouldn't exactly make a good paint, though they did better the finer they'd been ground. I think what I may have to do instead is first wet the tiles and sprinkle them or dip them in color. This is an excellent opportunity to experiment with different kinds of glaze and see if lime actually creates interference in the process without losing a great deal. Once I was done, I checked on the array again and made more adjustments as needed, occasionally having to undo previous ones. It was going to be a while before the tiles were ready for cooking, so in the meantime I tried to think of a few more things I could use the array for. One of the problems I noticed as the lime cooked was that it was creating steam that bellowed out of the vents on the sides of the kiln and blocked more light from getting in. That told me that I needed to make an additional venting system for gases, and ideally acting as a distiller, like my other kilns, so I can collect water and other useful chemicals from cooking. This will require a second dedicated cooking vessel inside the array, which can capture light energy and conduct it straight into the cooking medium and pipe gases straight out. For the moment, though, I'll content myself with building the pulleys for the dumbwaiter I mentioned earlier, which I can easily attach to the support posts. Once I was done with that task, I found I still had some time on my hands before the end of the day, another what now moment. I sat down to have a rest and think, admiring my solar array, and a few things occurred to me. Firstly, I should put some kind of pot or funnel under the panels because they're going to collect water when it rains. Second, the slightest breeze shakes the panels, visibly taking them off focus, for which they partially compensate, but this does cause me to worry about the panels becoming damaged in a major storm. This gives me an idea for a mechanism that would cause the panels to automatically retract if they experience an excessive force. And thirdly, a few stray bright rays hit my eyes today, and that tells me that the glazing on the panels wasn't perfect, and I should take the opportunity to polish them, probably with the potash I've been using for toothpaste. That gave me a couple of things to do for the next hour or so. For the auto-retract mechanism, I took some of the spare rubber and made a few more beefy rubber bands for each panel. Then I drilled a hole into the support post and installed a snug peg to each. To the pegs, I tied the ends of the panel support lines on one side and the beefy rubber bands already under tension on the other. I then applied a little extra weight to the ends of the panels to simulate wind stress. If the force was great enough to dislodge the pegs, the rubber bands were free to pull the panel into an upright position where it would be protected, like the closed petals of a flower. And for added safety, I rigged them so that if one tripped, they all would. However, I found that the rubber bands weren't strong enough to fully retract the panels, even with a mechanical advantage from the pulleys, just to gently lower them to the ground. So I found some rocks and used them as counterweights to retract the panels instead. Once that was done and tested, I decided to spend the remainder of the day polishing the panels. I got some ash and water and a bit of scrap cloth, and polished one of the reflectors. I then conducted a subjective test to determine if the panel had been dulled by the abrasion or polished, by comparing both how brightly my hand was illuminated by it relative to one of its neighbors, and by viewing the reflectors from the side to see how much light they scattered. I proceeded to polish the remainder of the panels before it got dark, lowering the panels to the ground one at a time to make it easier on me. This still was becoming a massive pain on my arms by the end of the day, though, so I had the idea to remove the reflector plates one at a time and attach my polishing rag to the drill press to make it do the polishing for me. I'll probably have to recalibrate the panels again later, however. As the sun started going down, I finally removed the lime I'd been cooking all day, probably longer than I needed it to. I set most of it aside, stockpiled for future projects, but some of it I used immediately. Now that the mosaic tiles were dry, I used the lime mixed with some water, producing hot calcium hydroxide or slaked lime, to paint several of the tiles white. Some I then dusted as planned with green and blue, and others I left their natural red and brown colors, before coating them with different glazes, some ash, some salt. I wanted to have them ready for tomorrow, so I sacrificed some firewood for the project before having dinner and getting ready for bed. I'll have to test the pottery firing abilities of the array another day. Week 10, Day 7. I woke up a little sunburnt this morning because I snagged my basket hat and it came apart the other day. I was so busy with the array that I forgot to replace it, so now I'm burnt and I'll have to make a new one. I checked on my solar array before getting started with my morning chores to make sure it was calibrated properly after removing and polishing the plates yesterday, and I noticed something unexpected. The interior of the array was cold, like really cold. What I thought at first was some kind of residue left behind in the steam from making the lime yesterday turned out to be honest-to-goodness frost, which melted in my hands. I realized the same effect that theoretically allows the kiln to become as hot as the sun also causes it to become as cold as the void between the stars, which is only about 2 Kelvin, just above absolute zero. This means I could theoretically use the kiln at night as a freezer, once it's cooled off, of course. And it reminds me of something I heard once where I think the Babylonians built huge buildings that acted as refrigerators for storing ice, produced by exposing pools of water to the cold of space each night. I think that's a bit of a stretch for me at the moment, but it does give me some ideas and hope for feeling cold again. Glorious, glorious cold. For the time being, I proceeded with my morning chores as normal, and with no better ideas for what to use the solar kiln for today, I just made more lime. I then took the time to start making a new basket hat. Can't have that happening again, and I can't just keep using my equipment till it breaks. I have to fix it before it breaks in the future. I then checked on the tiles I cooked overnight and saw that there was little overall difference in the effects between different types of glazes. I also found, fortunately for me, that the impurity of the sand I'd been using for producing lime meant that there was already a lot of silica in it, which reacted to produce a white tile with a shiny glaze after all, though the solar array is no better or worse without it at this point. This means, though, that there will be plenty for tiling the kitchen, which I'm going to start working on now. First, I need some kind of grouting to stick the tiles to the walls, and I can think of 2 options. The first is to just wet some clay and slap it on, knowing it should dry mostly hard later. However, this also means it could flake off later as well, so the second option is to make some actual grouting, which I can make with the lime I've created. I forgot up to this point that it's a critical component in cement, though right now I can't recall what the other key components are. I think the lime is basically being turned back into hard calcium carbonate, but if that was the case, concrete would absorb CO2, and I've always heard of it producing CO2. Maybe that's just the manufacturing process? If that's the case, though, the material I need to add to the lime needs to contribute the necessary carbon to the reaction. No, that's definitely wrong, because the curing concrete of Biosphere 2 created enough CO2 to ruin the balance of the system. I've been racking my brains trying to remember what I can about concrete. It was invented by the Romans back in the day, so what materials would they have had available to them, besides the lime? Which, on a side note, begs the question of where they got so much to build all their buildings out of. I remember a lot of ancient buildings around there were made of a substance called tufa, which was just compressed volcanic ash. Makes sense since the Mediterranean is lined with volcanoes, like Pompeii. Fortunately, I have the same materials available to me. But is it really that simple, though? I got some of the clay soil I've been using this whole time, mixed it with lime powder, and added water. It got hot and steamy, unsurprisingly, which told me the desired reaction was apparently occurring. Now I not only have a strong grouting for my tiles, but I can make concrete in the future if I need to. I got started on some spots I didn't mind the experimental grouting failing on, and gave it a try. Seemed to hold, so I kept using it. I spent a few hours installing tiles on the kitchen countertops, which will be nice because it'll make them easier to clean in the future. Each tile is about 1 square inch, and I made a full kiln of tiles, about 90 square feet, or 12,960 square inches, and the placement of each tile took about 5 seconds to grab, dip, and press into place. So it should take 18 hours to place all the tiles, or 12 minutes per square foot. A good continuous project, and kind of relaxing and meditative if I can keep myself focused. This is easier to do when I have a pattern to follow, and I'm trying to place tiles as quickly as possible. For that reason, making the surfaces artistic really does help my psychological state, in that it avoids letting me get bored, because when I get bored, I start getting depressed. As such, just for the heck of it, I've decided to illustrate the countertops with the various recipes I've been using so far. I'm not really sure why this appeals to me. It's not like I'm going to forget, and I doubt anyone else is going to need them. though the idea of leaving environmental hints in the scenery reminds me of my favorite puzzle games from back home. In a way, I wonder if this is like leaving a record to anyone who comes along after me of who I was and what I did here, if perhaps I never make it off the island. For some reason, this appeals to me too. I didn't even notice the time flying by as I tiled, like building a puzzle. Before I knew it, my stomach was growling, so I stopped for lunch. While I ate, I did a little math to estimate how long it would take me to tile the kitchen, and how much tile I would need. If the kitchen has a diameter of 10 feet and the counters are about 1 foot deep, then they have a surface area of about 25 square feet, subtracting about 3 square feet for where the doorway is. Double that if I want to give the layers of shelves about the same treatment. The walls then have a surface area of about 190 square feet, minus about 30 for the door, windows, and kiln. And the dome at the apex about 30 square feet, minus 1 square foot for the oculus. Up to 270 square feet in total, 3 batches of tile, 54 hours, or 6 days full work. Like I said, a nice, long-term project. Not that I plan on coating the whole thing from top to bottom. The lab may require something closer to that, though, in addition to the floor being tiled, which would be an additional 78 square feet, 1 batch of tile, or 15.6 hours. That could probably be done quicker, though, if I used larger pieces of tile. And like I said, it doesn't need to be pretty in there, and the workshop doesn't really need any such treatment. After lunch, I got back to it, making up my mind that, to save time, I would use up the small tiles for detailed mosaics, like the ceiling and such, and make larger tiles later for areas where details weren't that important. I hardly noticed the passage of time until, surprise, it was evening. By that time, I'd more or less finished the fresco on the ceiling, and although a good amount of it is picture, I can tell that it's noticeably brightened the interior of the kitchen. Around the oculus, I used some yellow and orange tiles to create squiggly radial lines to represent the sun, and while most of the ceiling was white, around the edges I made representations of the island. About 1/3 of the circumference was given over to the ocean with blue tiles and artistic depictions of the various fish I've caught. Another third was given over to the beach, split across opposite sides, mostly with depictions of the coconut palms growing there. The final third was given over to depictions of the island, showing the bananas, breadfruit, figs, vanilla grass, taros, and yams for plant life, and chickens for animal life. I also thought to make this show a bit of my story and accomplishments, so on one side of the beach I made a depiction of myself washing ashore, with some more yellow tiles depicting my raft, and on the other my beach hut and trotline mechanism, with a depiction of me holding a fish. I noticed that while I tried to aim for a certain aesthetic, and the various pictures of Greek mosaics seemed clear in my mind, when I actually started making them, the details seemed to wash away. What I ended up with was a little closer to a more familiar pixel graphic look, which was alright by me. On the ocean itself, I made a depiction of myself on the raft holding on for dear life, with a stylization of wind blowing against it, a reminder of a bitter moment, and for a moment I wondered if it would confuse viewers, thinking this is a story of me dying at sea. But then I remembered that if I died at sea, who would have made the fresco depicting it? On the forest side of the fresco, I included my birdhouses for the chickens and the garden. The whole thing was kind of a stroll down memory lane, and a reminder of just how far I've come in what is frankly an amazingly short amount of time. Although I'm going to go to bed rather sore from working upside down for hours and not realizing it, in my heart, I'm encouraged. The mural is not just my story so far, but a list of things I'm thankful for. As I tried to drift off, I thought about how I always had such a hard time at home being thankful, even though I knew I should have been. Maybe the reason was that, in modern society, things have become so effortless to acquire or produce that they just don't have as much personal value anymore. On the one hand, that's a good thing for maximizing the survival and comfort of as many people as possible, which was always my goal up to this point, but on the other, out here in the real world, where everything takes a lot of effort and planning to do, and your life is balanced on a razor's edge, you jump for joy at the sight of one banana. Perhaps this is evidence of a relationship. Gratitude is proportional to effort or perceived effort. That's probably not the whole story, but it's something to think about, and something I thought was worth getting up and writing down. Something to make me reevaluate my priorities. I'm not saying that I should stop trying to make my life or the lives of others easier, but at the same time, there seems to be something to be said for difficulty and challenge, bringing out gratitude and making life feel better at the very least. Blooper Reel, which may reflect with, and I already, because the angle of the plates will need to be at best, will need to be at, why is there a comma there? So I took some time to plan my moves for tomorrow. Before? Why did I write that there? Anyway, once I knew when I got back, the reflector mold was ready. So I pulled it from the kiln. It's a difficult question. Do I leave the door open and have cats continue to ruin my recordings? Or do I leave it closed and suffocate? Difficult decisions indeed. Now let me see. Where was I? Although I'm going to bet. All this talking hurts my tonsils. Words have lost all meaning. At most, I think it would be cool to make some tiles of the periodic table of elements. Hold on, I need to correct something. And the placement of each tile took about 5 seconds to grab, dip, and press into place. And there should be an if in there somewhere. And the placement of each tile took about 5 seconds to grab, dip, and press into place. So it should take 18 hours. So it should take 18 hours to place all the tiles. Oh, this is all messed up. Hold on. Hey there! Thanks for listening all the way to the end. I'm honestly pretty proud of my total internal reflection solar collector, and I feel like my true creative powers really got a chance to shine on this one. And now, with access to all that energy, there's no limit to what I'll be able to do. So, if you want to find out what I make next, you can press the subscribe and bell buttons to get notified when my next adventure is ready. As I've said before, I don't want to monetize these videos. I want to share my stories for free, just like the sunshine. But it would still help me out more than anything else if you could share this video with someone if you think it would brighten their day. And since you apparently liked it enough to watch it this far in, consider pressing the like button too. It would certainly help brighten mine. There's also a dislike button you can press if you didn't like it, but I can't imagine why you watched this far in if that were the case. Did you think there was something wrong with my science and engineering? Let me know in the comments. I actually like being told when I've made a mistake so I can learn from it, so long as the correction is polite and well-intentioned. If you can think of ways to maybe make it better, other ways to use this technology to help people around the world, or anything else this episode made you think of, I'd like to hear those thoughts and stories too. That said, thanks again for listening, and hope to see you here again next week.